Okay, so we want to start chapter 7 by talking about operations on functions. So yesterday we added, subtracted, multiplied, and divided. Today we want to talk about a new operation called functional composition. So functional composition is defined as follows. Suppose f and g are functions such that the range of g is a subset of the domain of f. Right? That makes no sense to you, but that's okay. The composite function f of g can be described by the following equation. So this open circle, it kind of spells the word fog. This open circle means composition, so it's not a time sign. And the way we say that is we say f of g. And what that means is that you can replace that open circle with a set of parentheses or brackets, right? That's the same as saying f parenthesis g of x. So what that means is instead of multiplying, you're taking one function and you're putting it into another function, okay? So first of all, we're going to skip this example. The book tries to use this to show you how it makes sense, and it always just seems confusing. So just write skip on your notes, okay? What we are going to do is we're going to look at equations. And so it says find f of g of x and g of f of x for the following functions. And so if f of x equals 3x squared minus x plus 4 and g of x equals this, find f of g. So I went ahead and wrote this for you. And this is what I recommend that you do every time because it kind of tells you the order. F of g. Think about what that means. Don't write this down maybe, but remember what f of 2 means. F of 2 means that you take 2 and you plug it in for x for each one of these. So we're going to do that, but instead of using a number, we're going to use the whole g of x function. So I'm going to say leave the f here, and I'm going to replace g of x with 2x minus 1. And that means everywhere there's an x in f, I'm going to replace it with 2x minus 1. So look what I have here. I have 3 times, instead of x squared, I'm going to put this in there, 2x minus 1 squared, minus, instead of x, I'm going to replace it with 2x minus 1, and then I have the plus 4. So kind of look at this. You can see that this has replaced the x in that original problem. Okay? And now I just got to work it out. And this is where you have to really use your algebra skills. So step 1, I'm going to FOIL this so I get, right, remember that means there's 2 of them. That's 2x minus 1 and 2x minus 1. So that's 4x squared minus 2x plus 1. And then if I distribute this negative, that just becomes minus 2x plus 1. And then I still have this plus 4. So I still have a little bit of work to do. I would get 12x squared. I'm going to distribute the 3 to these parentheses here. Minus 6x plus 3. And then I just still have all of this. I'm going to go ahead and say 1 plus 4 is 5 and add that together. And now I'm just going to combine like terms. So I get 12x squared. And then negative 6x and negative 6x is negative 12x. Minus 2 more would be negative 14x. And then 3 plus 5 is 8. And that would be my new function. So we've taken those 2 functions and we've made a new function out of it. Now notice if we do it the other way, the order changes. So if g is on the outside now, if I say g of f of x, now f of x is in the middle. So g stays here, and I'm going to put this whole f function, 3x squared minus x plus 4. And I'm going to plug that into the g function now. So now look at g. Think about what you would do if it was a number. If I said find g of 1, what would you do? You would replace this x right here just with 1. But instead of doing it with a number, we're going to do it with this whole function. So all I'm going to do is replace that x with all of this, which is 3x squared minus x plus 4 minus 1. This way, when you go this way on this problem, it's not as much work, right? We don't have to FOIL anything. We just have to distribute. So I get 6x squared minus 2x plus 8 minus 1. So the only thing I can do is the 8 minus 1, which is 7. And notice they aren't the same answer because it matters the order that we do this in. Okay, that's called function composition. So we're going to skip this one because I want to do it together in class tomorrow. But we're going to do the f of g and the g of f so that you can practice that one tomorrow in class. And then I want to show you that we can do this with if they give you a number too. And so we'll do a couple of these and then we'll do the rest in class tomorrow. Okay, so it says if f of x equals 4x and g of x equals 2x minus 1 and h of x equals x squared plus 1, find each value. So now instead of giving you an x to here, instead of getting a new function with x in it, you're now going to get a number answer. But again, it's layers, and so you always want to start with the innermost layer. So on this one, I'm going to leave the f here, and then what would I do to do g of negative 2? Well, that tells me to go up here to the g function, and where there's an x, I'm going to replace it with negative 2. And so I would still get f on the outside, and then negative 4 minus 1 would be negative 5. So I did the inside layer, and now I'm going to do the outside layer. And f of negative 5 means up here in the f function, I'm going to replace that x with negative 5, and I get negative 20. So your final answer is the answer to the whole problem. Don't give me the in-between answer. So what about if we did this one? So I want you to try it first and tell me what you get, and then we'll check it here. So hopefully, the first thing you did is you started with g of 3. So g of 3 means I go up here and I do this first. I plug 3 in here. So 2 times 3 minus 1 would be 6 minus 1, which is 5. And then I plug 5 into h, which would give me 5 squared plus 1, or 26. Okay? We can also do that with 3 numbers here. And so I'm going to rewrite this, and maybe you can try it, and then we'll finish up talking about it tomorrow in class. But remember, each one of these little circles means a parenthesis. So we could write this as f parenthesis h parenthesis g of 2. So now instead of 2 functions, we're now going to actually do all 3 functions, starting with the innermost. So see what you can get there, and then we'll do these together in class.